All right, here we go. Our objective for today: I can solve and graph quadratic equations by completing the square. Let's read together. 1, 2, 3. I can solve and graph quadratic equations by completing the square. So, we don't need a Freire model because we already know what quadratic equations are, right? But we do need steps. Copy these steps, please. There are only 6. Only. Number 1, set the quadratic equation in standard form. Step 2, divide the entire equation by the leading coefficient. Step 3, eliminate the constant. Step 4, add b over 2 squared to each side of the equation. Step 5, factor. Step 6, take the square root, write 2 equations, and solve. Copy that, please. So check this out. Pretty much all these steps we already know, and we know the terminology and everything in it. The only one that's a little bit off is number 4. You guys notice that?
Yeah.
That's going to be a step that I'll explain once we get there. However, to get us started, before we get into an example, I want to explain visually, first of all, what completing the square means. Here we go. So, today's lesson is completing the square. So what does that mean? It sounds familiar, doesn't it?
Yeah.
Square, complete a square. Okay, that sounds familiar. So if I was to give you some tiles like these, we know that this represents what? X squared, and this represents what? X, so there's 4 of them, so therefore this is x squared plus 4x. Is that correct? But don't you guys notice that this looks kind of weird without a number at the end? That's what we mean by completing a square. We want to find out what number should go at the end to complete this trinomial. So watch. I'm going to rearrange these so they can make a square. So I'm going to bring this over here, and then there, and here's the blue one. So do you agree that x squared is here, and these are 4x's, right? Do you guys see now the gap on the square? Yeah, so if I was to close that gap and draw the partitions, what am I missing? 1, 2, 3. What am I missing? 4. So what I'm missing is 4. If we had 4 here, now we have a perfect square. So does everybody see visually? Do you see it now?
Yeah.
Now let me show you what we did in the past with a pattern. Remember when I said check and see if this is a perfect square. Square root of the first. X, square root of the last. X times 2, that's 2x. Double that, is that 4? Yes, so my factors are x plus 2 times x plus 2. Do you guys see it now? That's what it means to complete the square, to find this missing number. That's the process that we're going to use today to solve quadratic equations. So with that said, copy this down, please. Example number 1. On the side, I'm going to leave the steps over here so that we can check off the steps. And so you can have them right there in front of your screen so like that we see them and we do the step. So it says, example 1, solve by completing the square and check your answer. Yeah, copy the verbatim, please. For the purpose of this lesson, we're not going to check. We already know how to check. But for right now, we're just going to complete the square and solve the equation. So just write example 1, solve by completing the square. X squared minus 4x minus 6 equals 0. Okay? Alright, so check this out. Pens down, eyes up here. I'm going to do a couple of steps and then I'll ask you to copy. So stay focused, please. It says, set the quadratic equation in standard form. Look at it. Is it in standard form? Yes, from highest degree to lowest degree. Step 2, divide the entire equation by the leading coefficient. What would be my leading coefficient here? 1. So if I divide everything by 1, wouldn't it be the same thing? Yeah, so it would be redundant to do the same thing again. The only thing that I wanted to show you is that the leading coefficient is 1, therefore I can divide by 1 and I end up with the same thing. However, if I had an equation that had a leading coefficient of 2, what number would I divide everything by? 2. Everybody understand that, right? So let's just imagine that we already divided by 1 and we end up with the same thing. Are we there so far? Alright, so therefore, we're on step 3. Eliminate the constant. Last night's home play was to practice identifying A, B, and C. Remember that? Well, guess what C stands for? Constant. Therefore, what is C here? Negative 6. So it says eliminate the constant. How can you get rid of the... Add 6 to each side. Therefore, we end up with x squared minus 4x. Leave a space here equal to 6. Copy that, please. All right. Pens down, eyes up here. Here goes the next part. Pay attention. I introduced this lesson with tiles so you can see visually what is completing the square. Is that correct? So now, do you guys see, if we look up, that this is missing a constant here? We need a number here that would make this a perfect square. And you're saying, well, why don't we just bring the 6? Because the 6 does not make it a perfect square. We need a number here. How do we find that number? Using this formula. Step 4 says b over 2 squared. Add b over 2 squared. So before you do the step, hold on. What is b? Negative 4. So that means I'm going to add b over 2 squared to each side. Pens down, pay attention please. So now I'm going to simplify that. Watch. X squared minus 4x plus, what is negative 4 divided by 2? That's negative 2. Negative 2 squared is positive 4. Is this a perfect square? Yes, because now I completed it using this process. Therefore, this is 6 plus 4. Copy that, please, and then I'll elaborate more on it. Yes?
I have a question. How come the negative 6 is right there, the constant, if we don't need it?
Oh, because some equations are going to give you a constant that does not make it a perfect square. That's why we need to get rid of it and fill it in with a number that would make it a perfect square. So now, this is what we did. Look up, please. I introduced it like this. I said there was a number missing, and I filled that number that's completing the square. Does that make sense? So now, what we're saying is that this is a perfect square. Are we there? However, let me show you the next step completely. I'm going to do that in green, which is factor. So then I would open 2 parentheses, factor the first term. Power Rangers, we got 4, negative 4. What factors of 4 add up to negative 4? Negative 2 times negative 2. X minus 2, x minus 2. Do you see that they're the same? That's why this is a perfect square. However, watch. Before you copy this, I showed you this process because that's what we call factor, right? However, don't we know already that this is a perfect square? Did I show you a pattern on how to factor a perfect square? Square root of the first, which is x, square root of the last, which is 2. 2x, double that, is that 4? Yes, and it's got a subtraction, so this could be written as x minus 2 square, and I bring this down. Copy that, please.
That's it?
No, we're still not done. That's it for step 5. Copy that, please. So up to the right there, we're good, right? Now check this out. Before I give you the next steps, let me just elaborate a little bit on square roots. I'm going to take you back to the beginning of the year when you guys were baby 8th graders. And I remember that I said square root of 16, which meant what? 4 times 4, or negative 4 times negative 4. Therefore, that's why we end up with plus minus 4. Are we there so far? Okay. So, now check this out. What if I did this? Let me show you some math magic. Here we go. So what is 4 squared? So now, to go backwards, square root of 16 is, check this out. What did I just do? It canceled the squared. What is the inverse of a square? Square root. I'm taking you back to the beginning of the year when I covered inverse operations. Let me show you another one. What is 5 squared? 25. To go backwards, square root of 25 is 5. How do we end up with this if I start with this? Square root of this cancels this. What do I have? Everybody see that? Okay, so, with that said, now we can do the next steps. Here we go. Step 6 says, take the square root. Why? What do you see here? And we need the square root to cancel the square. Whatever we do to one side, we do to the other, so therefore this cancels this, we're left with x minus 2 equals plus minus square root of 10. Copy that, please. Boom. So step 6 is take the square root. Did we take the square root to cancel that square? Yes. However, now it says write 2 equations. I can't yet because right now I still have an x and I have something next to it. What do I need to do to get rid of that negative 2? Add 2, add 2. So we're left with x equals 2 plus minus square root of 10. Now let's write our 2 equations. My first root is 2 plus square root of 10. Do you guys see that? There it is. What is my second one? X of 2 is 2 minus square root of 10. Well, since this is an irrational number, we can't get a perfect square root out of it. We leave it like that. So therefore, hold on, box it, and these are my solutions, x-intercepts, roots, zeros. Alright, now, the good thing for you, good news, is that whenever you end up with roots that have a radical, you don't need to graph. But whenever we end up with 2 roots that don't have radicals, guess what? You graph. Everybody with me? So let's go through the process again. Step 1, standard form. It was already in standard form. Step 2, divide by the leading coefficient. It was 1, so it stayed the same. Step 3, eliminate the constant. We added 6 to each side. Step 4, add b over 2 squared. Why do we do this step? Because that's what we call completing the square. Are we there? To each side. From there, factor. Now, box this part right here, and if you want to make a note for yourself and say will not need to do this. Why won't we need to do this? Because you can do the what? The square root of the first, square root of the last, and that's how you get the factors. I just showed you the factoring long method so you guys can see how it's done using factoring using the diamond, right? Right. Are we there? All right, let's do another one. So that was example 1. Copy this one, example 1Q. We're going to do this one together, see if we can go a little bit faster. Here we go. Example 1Q. You don't have to copy the verbatim anymore. Just copy the equation. X squared minus 6x minus 16 equals 0. Let's go down the list. Is it in standard form? Yes, so we leave it alone. Step 2, divide by the entire equation by the leading coefficient. What is the leading coefficient? 1, so it's redundant if we show it, right? So it stays the same. Third step, eliminate the constant. What do I do? Plus 16 to each side. We're left with x squared minus 6x, leave a blank, equal to 16. The reason I want you to leave a blank so that you remember that that's why this is called what? Completing the square. We need to complete the square with a number there, right? Step 4, we need to add b over 2 squared. So add, what is b? Negative 6 over 2 squared to each side, plus negative 6 over 2 squared. So let's simplify that. X squared minus 6x plus, what is negative 6 divided by 2? That's negative 3 squared. What is, that's 9 equals 2. 16 plus 9. Next step, we do what? Factor. So square root of the first, x, square root of the last, 3. What's the sign of the middle? Minus, so that's x minus 3 squared equals 2. What is 16 plus 9? 25. Okay? In our last steps, we start with what? Why do we need to do the square root at the end? To eliminate this square. So square root of this, but whatever we do to one side, we do to the other side, plus minus. So this cancels this. X minus 3 equals plus minus, what is square root of 25? 5. Can I write my two equations yet? No, x is not solved for yet, so therefore what do I do here? Plus 3 plus 3. We end up with x equals 3 plus minus 5. Be nice. Now we can write our two equations, yes? X sub 1, tell me what to write. 3 plus 5, which is 8. X sub 2 is 3 minus 5, which is negative 2. And those are my solutions. X-intercepts, zeros, roots. Did we end up with a number that we can graph? Yay! So let's graph this. Well, yeah, because this one we end up with whole numbers. Here we go. So this is 8, negative 2. And what is my y-intercept? Negative 16. And there's my parabola. Boom. How are we doing? Just lengthy, right? Other than that, it's doable. What's that? No, not all of them are to do the entire thing. Some are just asking complete the squares. For example, so the question was, we're doing numbers 9 to 25 on the home plate, Mr. Q. Yes, but some of them are like this: x squared. Pay attention, please. Plus 3x and blank, and they're asking complete the square. What goes here? What goes there? Plus 3 over 2 squared. So this is x squared plus 3x. What is 3 divided by 2? 1.5. What is 1.5 squared? Whatever that is. So I'll just leave it as 3 over 2 squared. And you're done with that one. How about this one? X squared plus, still a lot of work? Yeah? 10x. How about this one? Complete the square. Which is? Plus 25. How about this one? X squared minus 12x. What goes here? Negative 12 over 2 is 6. Negative 6 squared is plus 36. There's several of those. All right. Let's go to the next one. Example 2. Copy this one. Example 2, do this one by yourself. I already did one. We did one together. See how you do with this one. T squared minus 8t minus 5 equals 0. Copy that and solve. Go. All right, let's see. T sub 1 4 square root 21 plus, and T sub 2 is 4 minus square root of 21. Hands if you got that. Okay? Here goes the process. Standard form, divide by the leading coefficient, which is 1, stays the same. Eliminate the constant, add 5, add 5. This is t squared minus 8t equals 5. Add b over 2 squared, so this is negative 8 over 2 plus negative 8 over 2. So this is t squared minus 8t plus 16 equals 5 plus 16. So factor, square root of the first, square root of the last, t 4 minus t squared minus 4, and this is 21. To get rid of the square, we do the square root, plus minus. So therefore we have t minus 4 equals plus minus square root of 21. From there we add 4 to each side. T equals 4 plus minus square root of 21. And that's where we write two equations, and we're done. Yes?
I feel awesome because we didn't use the negative 8t for nothing.
Yeah, we did.
Well,
We factored it.
Yeah, and just like, well, you can always do the long way.
Yeah, you can always do the long way.
Yeah, it saves it.
Yeah. Okay, copy this next one, please. Example 3.
I need more paper.
Ha 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 ha. Example 3. 3x squared minus 5x minus 2. Yay, we're going to work with fractions. Yay. Okay, thank you. Okay, thank you. Is it in standard form? Yes. Step 2, divide by the leading coefficient. What's the leading coefficient? Divide everything by 3. 3 divided by 3 is 1x squared minus 5 over 3x minus 2 over 3 equals 0. Eliminate the constant. What do I do? Plus 2/3 plus 2/3. This cancels. We're left with x squared minus 5 over 3x, leave a space, equals 2/3. We need to complete the square. What do? Add b over 2 squared. So watch. You're saying, how do we write that, Mr. Q? If it's a fraction, we can't write it over a fraction. Negative 5 over 3 divided by 2. Everybody see what I did? Negative 5 over 3 divided by 2 squared. Does everybody see? B over 2 is the same as negative 5 over 3 divided by 2? Yeah. So therefore, we know that we need to multiply times the reciprocal, so this is x squared minus 5 over 3x plus negative 5 over 6 squared equals 2/3 plus negative 5 over 6 squared. You can finish that at home by yourself. Your home plate for tonight is found on page 601, numbers 9 through 25 only. Have a good one, everyone. Enjoy your home plate. See you guys tomorrow. Bye. Be nice.